Working on an very interesting part of physics right now, perhaps one of the more challenging areas of traditional mechanics, and that is the concept of inertial and non-inertial frames of reference. For those people who don't know, an inertial frame of reference is a position in space where you judge motion, but that position itself is not accelerating. A non-inertial frame of reference is the opposite. It's a position in space, but it's actually accelerating. And in the world of mechanics, this creates two different perspectives that can contrast to some extent from each other. For example, if you're driving a car and you're inside a car and you're heading in a straight line and you make a very, very sharp turn to the right like this. So you make the sharp turn to the right like this. What most people feel or they experience is a sharp tug to the left. Now the question is, that sharp tug to the left, what is that force that actually causes that sharp tug to the left? You're turning right, you were going straight, and all of a sudden you experience this tug to the left. What is actually causing it? So if you look at it from an inertial frame of reference, that's from the perspective of somebody on the ground viewing you in the car, what they would say, well, it's quite simple. The reason why you feel the sharp tug to the left is that your body wants to continue moving in a straight line in accordance with Newton's first law of motion, but you decided to make this turn to the right. And because your body wants to keep moving straight, it's not actually that you are experiencing a force to the left, but you are experiencing the effect of your body wanting to maintain its position in a straight line as a consequence of what we call the body's inertia. Inertia, of course, being the tendency of mass or matter to resist a change in motion. So that's how someone on the outside would view what you're doing. So it's not actually a force, it's just the consequence of inertia. But how would somebody inside the car view it? Or how would you view it yourself? You experience this pull, it feels real to you, to the opposite direction that you're moving. How would you rationalize this? For you, it's a real force. And the difference is that you are actually in a car that's changing direction. It was moving with a velocity, let's say north, now all of a sudden it's going east. This car has undergone an acceleration. So from your perspective, you are existing in a non-inertial frame of reference, one that's undergone acceleration, and you experience a force which you feel is real. So you interpret it differently. You say that there actually is a force, and that force is pushing you in the opposite direction. So we call this force in physics, it's a type of fictitious force, we call it actually a centrifugal force. It acts in the opposite direction to the acceleration of the reference frame that you are in. So if the reference frame moved right, this fictitious force would move left, and you would experience a force to the left, which you would call the centrifugal force. And that's how you would see it in a non-inertial frame of reference. You would see it as an actual force. But somebody outside the car, in an inertial frame of reference, wouldn't see it as a fictitious force, but would just see it as a consequence of your body trying to maintain its position in space as a result of the fact that it has inertia. This is a huge idea in physics. It allows us to build devices, both horizontal and vertical accelerometers. It allows us to get a deeper understanding of artificial gravity, and it gives us a chance to dig deeper into the field of circular motion.